Well, but I guess it is time to get started, right? This is always as informal as ever, yeah.
Yeah, sure.
Um, well, I don't really have a specific agenda. I'm interested in hearing about what people are doing or what they're hoping to see. I can talk about the few things I'm working on, but I guess I'd like to hear if other people would like to uh, say other things first before I start talking.
Well, one thing that would interest me, maybe more than the specifics of certain benchmark kits, although that's also interesting, of course, is sort of like what benchmarks are useful right now, right? There's always this, you sometimes hear somebody saying, oh, this benchmark, oh, that's an old one. You shouldn't use that anymore. You should use TPCQ now. And oh, that was not a realistic one. Oh, that's a bad one. No, we should be using this one. What are they useful? Sort of sorting out. I mean, obviously, a lot of this depends on the use case and situation, but some more guidance, of what you should use or what's useful to use in what case. That would be interesting to me. I'm really
Yeah.
lost there.
Well, I mean, I think there's kind of a difference between sort of micro benchmarks, right, and macro benchmarks as well.
Right. I mean, micro benchmarks, okay, you set them up, I guess, for your specific use case, right?
Yeah. So you're like, oh, I made this change, so I'm targeting this thing, and I'm just doing writes, or I'm just doing this, and then, which is I find those very useful when you're targeting something, but to kind of go and do a run, and to say, how does this look for an actual customer behavior? Because there's no customer that typically runs like 100% read only, or 100% writes. So it's the thing I've been working on is trying to think about non-uniform distributions for benchmarking. And what I mean there is
data generation or
yeah, well, partially and so data generation and sort of how the queries interact with it, right? So like Sysbench, for example, has the opportunity to say, when I'm selecting a key to go grab, am I going to use uniform, or am I going to use some special distribution that puts some weird weight on the cache, right? Or the file system. But I mean, most things are fairly basic to start with, right? And they very basic queries. But when you think about doing joins, right? Like a lot of times people will have like parent and child, but the parent and child always have the exact same number of rows, as an example, right? Mm-hmm. So, you have 4 children for 1 parent, right?
Yeah.
And the thing that interests me is thinking about like, how do you build a benchmark that is somewhat reproducible, but also has the thing where some of the children have, or there's 1 parent per child, but there's also the case where there's 1 million children per parent, right? And does the database still behave and perform how you'd expect with different, data distributions, right? Because I think that's like much more
this is the kind of
world.
Almost, yeah. This is almost the kind of thing that I meant earlier, right? Like if benchmarks don't do that, then like what are they really good for, right? Maybe they are, but I just don't have that insight of what's a good benchmark to use.
Yeah.
Ideally, I mean, sort of ideal dream scenario would be, there's like 3 good benchmarks that we somehow designate that, yeah, these are, and then we have easily available toolkits for those, and then everybody can just compare them or run them or use them for their work. But it sounds like we're not at all at that anywhere near that situation.
Yeah, I mean, I think the 3 that get used a lot, at least internally for us, are PG Bench, obviously, because you just got to like check everything with that. Sysbench, because we use it to compare to other things like MySQL, and it has a few more options than PG Bench. And then I think we've been doing a lot of HammerDB work recently on the TPCC side, just as a slightly more complex one. And there's been lots of fixes that have, it's been good because there's been a lot of fixes that Jimbo and other folks have given back to that maintainer to make that way better for Postgres, because it was performing like crap compared to other databases on that benchmark. But that just had more to do with how the benchmark was written than like problems with Postgres. So it was good to see it resolved.
Yeah, and all three of those that you mentioned have been widely discredited by some people. So, you know, it's
yeah, I mean, there's still very simple benchmarks, right?
I'm not saying I necessarily agree with that, right? I think those three you mentioned do appear to be popular, but then you talk to like, oh, the MRDB is this and that, you shouldn't use it, and you know, I don't know.
Well, yeah.
I am curious to how you find HammerDB on the I'm trying to think of a nice way to say it. On larger systems. I've played with it a little bit, and I feel it's stressful is not the right word. I question how usable it is when you start getting much larger than 100 gigabytes, terabytes.
We've run up to 1,000 warehouses, or 2,000 warehouses actually is one of our larger ones that we run on our like 24XL size AWS instances. That still works pretty well. Our internal overall, like we have a competitive benchmarking team, and they've been pushing to like do stuff that's many times the orders of that, like 10,000 warehouses or 20,000 warehouses. They're working with the HammerDB folks on fixing some issues there, but it works pretty well up to 2,000 warehouses, and that's like, that stresses Postgres pretty well. I mean, I think the challenge with Postgres is that because HammerDB is, I mean, depending on the settings you use, is fully random, you end up with, most Postgres implementations end up with problems with full page writes, and then like that becomes just the bottleneck. And you know, whether that's realistic to real customer workloads, I'm not sure, but
yeah, because my biggest complaint with HammerDB, if we ignore all the nuances of what it does different than the other TPC implementation, is that you know, my old 20-year-old data generator, I can build a database like 20 times faster than HammerDB still.
Yeah. No, it's not a, I mean, we normally use the snapshot method, right, for a lot of our stuff, but
so you build it once and hopefully don't have to do it again.
Yeah, at least not for a while, right?
Yeah.
And I mean, there are some classic problems with that one, in that you pretty much need to run, like, you can't run more threads than you have warehouses, because you know, the way it operates on stuff, you just end up with like massive contention very quickly, right? So it's, you know, it's good in that it's more complex, but it does some things that kind of assume, you know, hey, I have access, I'm going to be able to do a whole bunch of stuff on this one warehouse, and you know, it's problematic. So, you know, if you want to run like a 2,000 thread workload, you need 2,000 warehouses, right?
Yeah.
Well, it's similar to PG Bench, right? That you have to have more scale than clients or whatever it was.
Yeah, but it's probably worse than PG Bench in that fashion. Like, it's similar but worse than it.
Yeah, and I sort of wonder if you know, anyone trying to run the H with HammerDB. When I looked at that, I don't see how that thing is usable for the H unless you're running like less than 10 gigabytes of data.
I know some of the guys internally have played with it. I haven't looked at it myself, so I don't know.
Yeah, it's just so slow for the H. The way that the H generates data, so slow.
Yeah. I mean, and the thing with something like HammerDB, I mean, is nice because it gets away from the like Sysbench, PG Bench problem of the network latency for, you know, doing round trips, which is really good. But then it's really sensitive to the stored procedural implementation, right? So, for example, like when we run it on MySQL, it's like we run out of CPU because MySQL's stored procedure implementation is crappy. And some of the things that we had them fix was some of the way they were using Postgres as stored procedures. But again, I don't know how realistic that is, you know, for real customers, because I don't think a lot of customers use a tremendous amount of stored procedure language when using Postgres, right? At least not in a performant fashion.
Right. They seem to be in the minority in the wild, right?
Yeah. So, yeah, I mean, maybe, I don't know, like if anyone's working on anything else, it'd be interesting, because I mean, I would love to get behind a more comprehensive benchmark that, you know, stresses the database in interesting ways from a performance perspective. So you could actually, you know, show real benefit that's closer to customer, you know, for changes, right? And whether that's
Yeah.
like testing a new CPU or testing a change to Postgres, right?
Right.
So what are you using, Mark, or what are you working on? Your sort of, I know you do. I know you do some benchmark work for work. So
The short version is that I'm revitalizing all the old TPC kits I have. If you read between the lines, you could say that the people who are tapping me at work all seem to be more interested in the TPC workloads for whatever they're looking at. So I updated my C kit. I remember a presentation that Jan did a few years back, pointed out where my implementation of the driver was antiquated by modern hardware. So I actually fixed that up to be event driven as opposed to pthreads. But so a couple things like that, modernizing it so that you could use it with UTF-8 instead of having to use ASCII. Some things like that. I've seen on the list that, well, let me go one by one. I think it'll be easier. So the E is the successor of the C, but if you look out on what's in the wild, there's still only SQL Server results for the past, what is it now, 10 plus years. So anyone who's interested in the E is probably someone who's already running SQL Server, because I don't know who else would be interested in an E. Oh, I know. Mr. Gagan's interested in the E because he thinks that the transactions in that is more interesting. They're definitely more complicated than the C for sure. And I mentioned earlier on the planning thing this morning that we have a Google Summer Code project to update the E. When the original Google Summer Code project that we put that together was before all the sub-transaction support. And the E is actually written so that, well, not so that, but it was written with sub-transactions for many of the transactions. So of course we couldn't implement any of those originally. Let's see, then the H, it seems like Postgres still doesn't run the H very well. And I've forgotten at this point what was really so wrong. Well, that's not the right way to put it. Where the huge gaps were for Postgres to run the H well. I can't remember now if it's a parallelism or something like the bitmap indexes, but some of those queries still run really badly in from the H. Then there's the DS, which is a star schema snowflake decision support benchmark. I slapped something together for that, but my kit still needs some work to run that a little more smoothly. But I wonder how. I think I still kind of have some of the. I have a lot of the same questions that Grant you said. That I don't know where the interest is, but it is, you know, a star schema benchmark. Snowflake is would be different than the ones that have been around. And the only other type of benchmark that I'm sort of aware of that could be interesting is that Peter, I think you actually might know what this is, that graph database, not graph database, but the graph query. Remember, the 4-letter acronym starts with an L, LS.
LDBC, yeah.
Yeah, yeah, yeah.
Yeah, that one I'm
so that
actually quite interested in, but we'll come back to that maybe.
Yeah, it does make me a little sad when I look at it that it's implemented in Java because after what everyone heard me say about HammerDB, I kind of say the same sort of things about all of these Java implementations like benchmark SQL and OLTP bench and stuff. I question how usable those are when we get up to a certain size.
Well, but a lot of customer applications are written in Java, so using Java to test things is not unreasonable if you want to be realistic, right?
Oh, right. So that in itself, I totally agree with you. Where the problem is that these Java-based test kits just aren't written in a way that they perform well with hundreds of gigabytes, terabytes of data. So I know it can be done, but not with these kits, not with the way that these kits are written.
Well, LDBC is like LDBC has multiple benchmarks under it.
Yeah.
There are some of these are sort of more like slow running queries, so I don't think you don't need like super concurrency really there. So
yeah. So there's two parts. One is it still useful for the size that it can run well, for the scale that it can run well? Yeah, I'm sure they are. And the other thing I sort of wonder about, just being a little more familiar with seeing what people are doing with HammerDB and the OLTP benches, I do question whether how many of these people are really running on large systems as opposed to a little workstation they have or even their laptop. So, but these are kind of what's the right way to put it? Well, kind of nitpicky criticisms about just specific use cases where I
right.
see
I mean,
people
this is
using
like
these.
you benchmark either on your laptop or on AWS, right?
Yeah, right.
So that's, or unless you have sort of access to hardware somehow, but not many people have that. So a lot of that stuff gets ultimately only used in those two scenarios.
Yeah. And
I gotta check a call here at the moment. Yeah, being.
but I guess that's mostly me talking at this part. Who's left?
I'm left. Well, I've been sort of. Do you hear me?
Yeah, you're a little quiet, but I can hear you.
Okay. Some reason this stupid volume level is always reset.
No, I'm back.
Well, I was kind of trying to benchmark replication systems, and then I was thinking, is there a way to benchmark an update everywhere system? And well, I've very briefly experimented with Benchbase and PGBench, running them through HA proxy, so that HA proxy just redirects, let's say, 50% of the TCP connections to one node and 50% to another one. And there are no interdependencies between the work that the different threads do. And when I tried this construction using HA proxy, TCP load balancing, and Postgres Pro Multimaster, which is an eager replication system solution that uses three-phase protocol. Well, something like three-phase protocol. They are not very specific, but there are also many different definitions on what three-phase protocols are. And that just broke apart almost immediately because those independent nodes were waiting for locks that were held by transactions on the other nodes when PGBench was issuing updates there, and PGBench did just not at all react gracefully to that. So perhaps that would be fixable, just adding a retry option to PGBench, right? If the transaction fails because Postgres Pro, for example, tells you the multi-master solution tells you I can't run this transaction now because there is a deadlock that I've detected, then just retry it in a bit.
Well, the same could apply locally if you have a deadlock or serialization failure. Right? I'm not sure how often that happens in actual benchmarks, but it could happen, right?
I mean, if with a regular Postgres, if you have a deadlock, is that even detected by Postgres itself?
Yeah, I mean, so you could have, depends on transaction isolation level. You can have deadlocks or serialization failure, and you should retry in that case.
Yeah, and
so that that could be done.
PGBench would also just throw up its hands, but interestingly, not in general. It breaks sort of one thread at a time. So one thread breaks, and the other ones would keep running, I believe. I mean, we don't have to get into too many details on replication here. Just that is something that I had on my mind. I don't know if there is anything from the TPC committee corporation, whatever that is, that targets replicated systems.
I wasn't sure if I was understanding correctly. When you were talking earlier about the HA proxy, was it to run against like a multiple database nodes to distribute like that?
Yeah. So one.
He has a multi-master system, so he distributes the load around the multi-master system.
Okay. So when the TPC kits, well, the TPCC kit that I have, we actually wrote that originally, knowing that if we ever got to it, our kit is actually able to be partitioned so that you can run different parts of the workload against different nodes of the system. So I know my kit can do that. I know. I think I understand what you were saying. The Benchbase and the HammerDB, you only can give it one system that it can run against. But the DBT2 TPCC kit, you can set that up to tell it which nodes to run against, which warehouses are there, how many terminals to run against that warehouse, that kind of stuff. The only caveat is that the binaries in my TPCC kit are kind of what's the right way to put it? Not bare minimum, but they do what maybe that is the right way to put it. They kind of do the bare minimum. You have to tell it exactly what to do, how many warehouses to run, what the think time, key time, warehouse ranges, whether you want it to fake multiple terminals, or you randomly generate what terminal district that you want to run, but you can tell it exactly what to do. there's no easy driver user interface to do it, but it works. I mean, it does work.
Okay.
The HammerDB Benchbase and stuff, no question, way easier to use than the TPC kits that I put together. There's no question. They're meant for that one click, start it up and run a test.
I think we could do more also with PGBench specifically to support sort of distributed systems more at all, right? Right now it's just like Hammer one node, and obviously we're kind of moving into that direction. And I know some of those are proprietary systems that some companies have, but so distributed systems have other failure scenarios that PGBench should potentially handle. So I think that's a reasonable thing to pursue to make PGBench more robust about that.
Yeah, that should be pretty straightforward.
I think there was also a patch proposed somehow to connect to multiple hosts or something like that in PGBench. So maybe that's sort of someone is thinking along the similar lines.
I have seen some of those arguments on hackers about not making PGBench too complicated. I wonder if it fell into that category, but I mean, I agree that should be something that's relatively easy to add to it.
Yeah, I think PGBench is already so complicated. I don't think that's gonna break its back. Yeah.
I don't see how a simple retry mechanism, for example, would really make things.
No, yeah, I think you can make it as an option if people are concerned about it. But
yeah,
I mean, I guess there's a way if again, it depends on what your use case is, right? If you want to test Postgres for a specific performance change you made, and then it errors out, that might mean your code is a bug, so you want to know about it as soon as possible.
Yeah, of course.
But if you're testing a distributed system and for certain error codes you wanted to retry, then you want that. So, that some fine tuning there is possible, but I think it's entirely reasonable to make some changes or propose some improvements there.
Yeah, to answer your question about what the TPC says in their benchmarks about retrying, I think it depends on the benchmark, because it'll say that if the transaction fails and you retry it, then you have to make sure you count all the time that you spent doing all the retrying as part of the transaction, and you can count it as a successful transaction. Some of them are going to say something like you have to count the number of time it fails and then count the time that it passes successfully. So the specifications do tell you exactly how they want you to count retries, whether it's successful, and how to factor that into the transaction rate.
And all of that specification, is that closed source somewhere, or?
Oh, no, it's on the tpc.org website. You can download the specifications are free to download.
No, really, I didn't realize that. I thought this was like some super secret club like the SQL people.
Oh, no. The only super secret stuff is the meetings behind what they're planning, benchmarks that are coming out, changes that are going in, what publications are being challenged.
Can we get in on that?
It's a membership fee. EDB was a member in the past. But yeah.
Didn't want to continue it, or?
Well, there are different reasons. If we're going to talk about EDB doing that, I can fill you in what I know about memberships and seeing if that's something worth pursuing. I don't think it's a trivial I don't know what costs are these days. I want to say that at one point it was like only a couple thousand if you don't want to vote, and maybe 10,000 plus if you wanted to be able to vote. The only other part that might be worth mentioning is some of the benchmarks do have codes applied by the TPC if you want to audit and do real publications. The the code has some restrictions on what you can do with it, how you share it. Basically, they're not open source. You can get your hands on it, and then you just have to worry about what you do with it, the sharing and stuff.
Yeah, I suppose like doing a validated benchmark run is not that interesting ultimately, because
Right.
you know there's no point in. I mean, we're not gonna go and try to compete with anyone really. It's more for our own validation and verification ultimately, right?
Right.
So maybe it's not all really that worth it.
Yeah, absolutely right.
If you can get the specs, then that's interesting. I didn't realize that.
Yeah.
So you mentioned you threw around a bunch of letters like C. I mean, obviously TPCC is kind of the one that most people know, and then for a while I noticed that people were sort of dissing C and said H is the thing, but now I guess it's
Oh,
back
yeah.
to C and E, or what?
Yeah.
What's your assessment of that? What's like the good stuff?
So to group them more appropriately, the OLTP style benchmark was the B, succeeded by the C, and the E was meant to succeed the C. But I think the short version is that there's probably some political drama, and they don't feel like they can. The E didn't totally do everything they wanted it to do, and I'm not just talking about technical reasons. I think there's some political things too. So the C is still around. So the C and the E are the OLTP style workloads. If we oversimplify the categories there, the decision support big queries is it started out with a D, H, R. So the H is the long-lived one at this point, and the DS. I don't know if saying successor is as accurate, like we would compare the C to the E, because the DS is a specific star schema, so snowflake design, where the H isn't. But those are the two in the decision support realm, and that's really it. If we ignore all the ones that have been obsoleted and decided more good benchmarks, like the Java one. And I want to say that there was another one, but there was a Java app one that was short-lived.
Okay, good. That clarifies things a little bit. So do you think, I mean, yes, I mean, we've run like C and E and stuff, and I guess PG Bench is kind of C a little bit, but how competitive do you think Postgres is in the decision support realm as measured by these benchmarks?
I don't think it is. So back in the OSDL days when I was running the C there, at that time, 15 years ago, has it really been that long? 15 plus years ago. I actually had a system, I had a system that was exactly the same as other published benchmarks. And so at that time, it was easy for me to say, hey, I have the same hardware. How well does Postgres run? It was very hard to get 50% off of the other guys, other commercial published results with Postgres. But 15 years down the road with the OLTP workloads, I think the gap is much closer. The H and the DS, I think the gap is still pretty large for Postgres, and there could be a number of reasons. So one reason is that the specifications want you to use specific query forms. They want you to use queries written in a particular way. And one reason could be that the planner just doesn't rewrite them in an efficient way. That could be one reason why some of the queries are running badly. I do remember, one of the reasons I don't remember this so well is actually someone else was the primary author of the HKit that we wrote, and she was doing most of this research. So I do remember some of the queries, some of the discussion on the list was like, well, why is it written that way? And of course, the way that discussion goes. Well, if you rewrite it like this, it runs fast. So it's because of some of the query forms that they make you use. I think I remember one of the other issues was being able to take advantage of something like a bitmap index, taking advantage of using like a hash index to do very specific queries that those kind of indexes are supposed to be much better than B-tree at. So I think there are a couple instances of that. I want to believe that with the DS more so than the H, that some of the queries probably perform better with the parallelism, or parallelism will close the gap in performing some of those queries better. Otherwise, that's kind of what I vaguely remember. What's the problem was with the H and the and probably with the DS.
Yeah. Kevin, did you have anything to ask? No, just lurking. Well, this was informative for me. Obviously, it would be nice to get some of these benchmark kits updated. At least I have a better idea now what is really like relevant and stuff. I took some notes here, so I'll summarize some of that maybe for the wiki for the program.
And I think in the spirit of open source, it would be nice to get something kind of TPC free, but that's just not a trivial amount of work to come up with a whole benchmark and figure out how to scale it appropriately.
To come up with your own benchmark? Yeah, no.
Yeah.
Well, the LDBC doesn't matter what you think of the benchmark and it's specific to graph databases, but it's I found it was interesting how they set it up. Like it's part of, it's a nonprofit organization of some sort, and they have this, open source specification of how it's run. They have reference implementations that you can run. It's all specified. There's like, scientific papers for it. It's at least there's some kind of peer review in theory, and then you can just run it or implement it yourself if you want.
Yeah.
I find that, it's a good model ultimately. I guess the flip side of that is that the big commercial vendors are not involved there. But again, it's like, is it worth competing in that way? That's probably not our strength, us being Postgres. I think I'm more interested in, the one thing with with the LDBC, what they call the social network benchmark, SNB, is that if you run it with current Postgres, it doesn't actually finish, or it like hangs at some point, or because it runs out of memory or something with some queries. Yeah, it has like a lot of these recursive queries, right? Because they're graph queries. So in relational database terms, they translate to recursive queries. And there's almost no planning support for that, right? The only thing it can do is like, well, here's a plan, but there's no cost estimation or anything for that.
Right.
So it has no idea how, you chase these links, how many hits you're going to get, and then how this thing is going to look. That's like, we're not even close to having, nobody's ever even looked into that. Like, what kind of cost models could you use for that or anything like that, right? So in Postgres 15, there's a setting where you can kind of control that. It's almost like an optimizer hint in a way. It's not statistics based or anything. It's just like, you can just set a setting as like, I think the output's going to look like that, so behave like that. And I haven't actually gone back, but what I read in the discussion was this patch came from Simon Riggs. So it would help actually make the benchmark finish.
Mhm.
So we're very small steps there, but that's something I've been looking at once in a while, just as a little challenge.
Yeah.
I guess I obviously you and your colleagues in your team, I know you guys are working on that a lot, but I guess once in a while it would be nice to have some kind of output. I know you work a lot on benchmark kits, and I know like some of the other people in your team do, but it's like at some point it would be good to like see some results of like, Postgres is this much faster now, and this, I guess you can't name these, like you can't say Postgres is this much faster now at TPCC, that would be not allowed. So it's almost probably a problem to really publish results like that, even if they're not competitive. Like if you just want to make a reference to like a well-known benchmark.
Well, using it for learning purposes, what's the right way to say it? Academic, is fine. If like we ran a C-like thing on version 12, and this is how our beta for version 13 is looking, and this patch is helping me produce this much better results. I mean, that kind of stuff is fine.
Yeah, but it's you get tricky, right? Obviously, if you put it on like, I don't know, like the EDB blog or something like that, or other cybertech blog or something, then it's already like you're a commercial player, and then it's not an academic resource anymore, right? So
yeah, there's that gray area.
But I guess if you say I ran sysbench and this is how it looks, I guess that's different. But then that's just a factual statement.
Yeah. Yeah, I think. Oh, go ahead.
Well, so the PG bench documentation is very peculiar, talking about being TPCB like.
Yeah.
And so at that point, are you free of any legal repercussions if you just keep mentioning that it is TPCB like? And would that apply to those benchmarks that are not currently obsolete as well?
So the first part of what you're asking, yeah, the TPC would be very happy if you always said this is not a TPCC benchmark. How it applies to the obsolete benchmarks, I sort of don't remember. If it's obsolete, then I don't think they put up any results. So you technically couldn't compare it to any published results.
And they are probably not intent on legally pursuing that if they have already made the benchmark obsolete.
Yeah, right. If if this helps.
I was just looking at the definition for TPCB, and that is older than I am, just by a few months, but
yeah, the legal stuff. If you were a member of the TPC, when you sign up to be a member, you do you do say that you will be subject to whatever fines the TPC will impose on you as part of a membership. For those that are not members, I don't think I'm aware of any legal action of the TPC going after a non-member, but I suppose that a lot of people who really, I think it's changed these days in the last 5-10 years and maybe 20 years ago. Companies that would be interested in making publications and making claims that the TPC don't like are probably more now than before. But the ones before, they would just be like, okay, yeah, we'll just sign up to be a member and then not worry about just try to do what they think they're supposed to do.
Yeah, I think then this is just general intellectual property law, right? And TPC is a trademark, so you can't use it for things that is not TPC, and there's copyright. But if you just like, you can say, oh, my car is like a Mercedes. Well, it's an opinion, right? It's not and this is
Right.
then up to the courts in detail, right? So it seems fine, I guess.
Yeah. Well, to one of the other comments you were making earlier, Peter, if I had hardware, I could run tests on a regular basis, but I really don't have hardware. I don't know if how easy it would be to get hardware to run these things on a regular basis like I was doing way back.
You're thinking
I
sort of
see
like
there's a
writing tests.
TPC-XBB. What are the TPC-X benchmarks?
Oh,
Do you know that? Are these experimental or like new ones? There's TPC-XBB, TPC-XHCI,
let me see.
TPC-XAI, and TPC-XIoT.
Oh, artificial intelligence. Yeah, actually, I don't know what that AI is
I
and
think
IoT.
that sounds like those are like sort of experimental ones, or maybe they're like beyond the database. That sounds like something that could be well, there's people. I'm just on the website here. There's people publishing results still. So interesting. Yeah, I mean, it's kind of at this point, it's like almost a commercial decision. Like, what do you focus your time on in terms of running it? It does cost money, and like having the hardware at the time and renting the hardware or whatever. So it's kind of the question of what you want to focus time on.
Yeah.
But I think again comes back to the top for me, right? Having sort of more clarity of what are the good benchmark hits, make sure they work, and then everybody can just go off on their own, right?
Yeah, I definitely think getting the E in better shape would be good because, things like the C. Well, here's one of the silly things about the C. You don't have to use foreign keys, for example. The well, and I think that goes. This is where there's conflicting things going on. You want to know how bad foreign key, or you want to know how good your foreign key implementation is. So you probably want to put it in and see how it works. But if you're just running the benchmark just to see how well you can run that benchmark, you're not running with foreign keys, so, right? There's kind of that kind of conflicting thing.
Well, I guess you can run it with and without, and then you again, is it for your, is it for testing your product again? Your development, your product, or is it for showing off?
Yeah,
oh,
right.
Here,
And
there's all kinds of benchmarks here. There's a big data benchmark. There's a virtualization benchmark. Oh, this is interesting. Well, I guess if you test virtualization, I guess you're testing the operating system and not.
And they're starting to do some energy ones too. So you run the test and you report how much energy you actually use to run that benchmark.
Oh, that's interesting.
Yeah.
That makes sense,
So
I guess.
Like another funny thing about the H and the DS too is that you don't have to use primary keys. You don't you don't have to use foreign keys, but and if you want to read between the lines, this is where it gets political and some of these benchmark how these benchmarks get written. There is some commercial system out there that does run better if you just use a unique index instead of a primary key. That's why some of these things are written that way. Oh, and I think for those of us who understand the technical, the things that you can do with a primary key or can't do versus a unique index, I think it's easy to argue reasons why it makes sense in some cases, but again, the way that some of these are written, the way that these specifications are written, is it about running the benchmark the way that it was intended to run, or is it about learning about how your system behaves? with a primary key versus a unique index or whatnot.
Cool. So there's going to be some more code work, and then we'll have some results from that.
Yeah, right.
I think it would be interesting to, I mean, maybe you've done this and stuff like that, but the kind of stuff that you explained to us and me here, I mean, this could be a nice presentation at some point, or webinar, or, you know, something like that. Just like, what are these benchmarks? What do they mean?
I recorded a TPCC one. I think it's tomorrow.
Oh,
Is it
great.
tomorrow?
Well, there you go. Then
Yeah, tomorrow. There's a TPCC one, or I did one for the TPCC.
cool.
Did anyone take any notes? Should we?
I took some notes. Yep.
Okay, great.
I'll post some of these. I mean, it's not a whole lot because we basically just sort of chitty chatted about what things are, but
You guys figured it all out while I was gone. Got a new benchmark
Oh, yeah.
written.
All
Covers
done.
everything.
First result is this afternoon.
Good stuff.
yeah, one thing we talked about. I mean, we kind of Mark explained a lot of what these different TPC benchmarks are, and but one thing we kind of noticed sort of as a concrete thing maybe is if you test distributed systems, then PGBench has sort of, you know, it's a bit too flaky at times. If there's sort of global deadlocks or something like that, it just kind of falls apart.
Yep.
So we will think about maybe adding some sort of, you know, retries or a little bit more awareness in that direction. I think would be
Survivability of errors.
generally useful. Yeah.
Yeah. Yeah. Yeah, good. Look forward to seeing the notes. Sorry, my meeting took longer than I hoped, but work.
That's all right.
And I guess Mark has a talk. I don't know if you just heard that. Mark has a talk tomorrow about his TPC. So
Yeah,
there's
gonna attend that.
some info coming up. Cool.
Yeah, if you already know everything if you already know all about the TPCC, I'm probably not going to say anything too groundbreaking.
No, I know very little, so I look forward to. I won't be there tomorrow, but I'll get it at some later point.
But does that mean there will be a TPCC implementation that's equally easy to use like PGBench?
I mean, that I guess we didn't talk about that. That'd be kind of cool if we could have, you know, either PGBench support for all these different, you know, either just as a script in PGBench. That'd be cool. Or is that problematic?
I think it's not trivial work to make PGBench run a TPCC properly. TPCC is complicated enough, more complicated than that. There's enough additional complexity in the C that makes it a big difference than the B. So, yeah,
I mean, that's what would really be nice if you could just, you know, run PGBench to run CE. Maybe the other one's a little more difficult, but
yeah. I don't actually like care that it's PGBench as much as it is simpler. Like, I mean, one of the things with HammerDB is it's fairly complicated for someone to set up and just run easily. So anything that's simple. I mean, I think the thing that we like about PGBench is it's, you know, you just like, bam, it's going, right? So.
Yeah. What does HammerDB implement? What test suite is it?
TPCC.
Oh, it's all TPCC. Okay.
Yeah. With stored procedures, via stored procedures.
It does the C and the D, and I want to say that there's maybe one other one, but if you didn't know, TPCC owns HammerDB now.
Oh, I didn't see that. Oh,
really?
I think it was a few years back.
Oh yeah, that's right too. No, I do remember that. Yeah.
Yeah. So
So they
TPCC
maintain
actually,
their own code, really, in a way.
it, I don't remember, I don't know who the original people were who put HammerDB together,
This is
but
that one.
someone from-
It's the one fellow from Intel, wasn't it?
Yeah, I talked to
Oh,
him
is
a
it?
while ago. Yeah,
Yeah.
yeah.
I think he's still involved with it. I think basically he just, yeah.
Yeah, because I worked with him on a different project, but
Hmm.
and he told me, "Oh, I'm the maintainer of HammerDB." But I guess maybe he, yeah,
I think it's
don't know
Steve
who-
Shaw. Yeah.
Steve Shaw. Yeah,
is-
exactly.
Hmm. Yeah, to your comment about making things easier, I do think of the ones I've seen, I feel like HammerDB is the easiest one to run because it's got that GUI that you could use if you wanted to. But one of the things, yeah, right. But I don't know if any of the other kits out there is easier. I do think that mine is the hardest, but mine was designed for someone who was really running the benchmark, not for someone familiar with the C to be able to run the benchmark, as opposed to someone who's not familiar with the C to be able to run the benchmark.
Yeah.
But again, to one of the things that my group at EDB has been working on is trying to leverage some of the open source things. I'm actually mentioning this in the presentation tomorrow too, but we have some open source tools to do provisioning and in various cloud, and not just the cloud services, but if you had your own on-premise virtualization thingy to do some provisioning in that, and then putting together playbooks so it sets up the systems to install all the kits and the whatever supporting packages, and even providing some specific ways to run the workloads.
Right.
So I'm hoping that will be a useful thing, but those were some ideas that we had about the whole along the lines of how do we make all aspects of this easier.
Yeah, we've built I think our 7th internal benchmarking toolkit thing to run benchmark. I mean, I've been in Amazon forever, right? So it's not actually that many given. It's like one every 3 years or something. But but it is like every 3 years someone goes, this thing that we're using to run benchmark sucks. We should build a new one. And 3 years from now, someone will be saying that about the current one. So, but
right.
It's never easy.
Yeah, because I think with the benchmarks on the complexity of the TPC ones, at least, it's more than just having a kit. Just because you have the kit doesn't mean you're running it on something that's useful.
Yeah.
And then, but that it's part of the whole complexity of the whole thing. It's not meant to be just run on anything.
Yeah. Yeah, I think the one thing we do like about HammerDB is that it runs on multiple databases, right? So it is somewhat of a comparison of different things, but the bad part is because based on its implementation, it relies on a lot of stored procedure code. And so, like SQL Server does better than Postgres, but is it because SQL Server is better than Postgres, or SQL Server's procedural language is better than Postgres, right?
Yeah.
It's not necessarily that helpful then. But yeah. Look forward to seeing your thing tomorrow.
All right. I hope it doesn't disappoint.
Yeah.
Are we out of time?
Well, I mean, we're up against the notional pub time here. So there's
yes.
reason to leave, but it's late for me, so if we're done, I would check out. And I'll put in the notes tomorrow.
Yeah.
All right. It was good to see all of you.
Yeah.
All right.
Until next time.
Yeah.
Thanks for hanging out.
Thanks. Bye.